Yo, what is up YouTube? In this video, let's take a look at elementary row operators. This is a linear algebra concept and it applies to linear systems. So as you see on screen, I have a systems of two equations with two unknowns. So let's first say, how can we transfer this into matrix form? So there's this thing called an augmented matrix. You just take out the coefficients. So we have 2 for x, 3 for x, 5 for y, 4 for y. And then we draw a line where the equal sign is. Some people draw a dotted line, some people draw a full line, some people don't even draw the line at all. So this is our augmented matrix. Now let's talk about some operations we can do. The first one that comes to mind is replacement. So replacement is when you have a scalar multiple, anything that's not 0 times a row, and you add it to the other row, and it goes into the other row. So this would be like 1/2 of R1 plus R2 is going into R2. So 1/2 of R1 is like, if we had this, it'd be 1/2 of 2 is 1 plus 3, and we're storing that value into this entry. And then 1/2 of this is 5/2 plus 4, and we're storing that value into this entry. 1/2 of this is 3/2, and then we're adding that to 6 and storing that into this entry. Next is something a little more simple. It's called interchange. It's a simpler way of saying swap the rows. It looks like this: R1 swap with R2. So in our case, we would simply do 2, 5, 3, 3, 4, 6. Easy enough. The last thing you can do is something called scaling. So scaling is like, let's scale row 1 by 2, and we're going to store that into row 1. So again, when you're scaling, it's like a constant value that's non-zero times that row, and you're putting that value back into the row. So in our case, it would be 2 times 2 is 4, 2 times 5 is 10, 2 times 3 is 6. So the top row would then become 4, 10, 6. So let's take a look at how we can use these elementary row operators in order to solve a systems of equations like this. We already know we can do it with elimination. Let's show ourselves we can do it with these elementary row operators, because with linear algebra, you can scale these techniques to like 4 equations and 4 unknowns, and it's helpful to have a grasp of these ideas. The example is -x plus y equals 4, -2x plus y equals -5. So first step is to translate that into an augmented matrix. Again, -1, -2, 1, 1, line, 4, -5. So now let's take a look at how we can get rid of some of these values using our techniques. Namely, we're going to use a whole lot of replacement. So the first thing I want to target is this 1. How can I get rid of this 1? The thing I want to do is multiply the bottom row by -1 and add that to the top row, and then put that answer into the top row. And that way we get rid of this -1, because that way we get rid of this 1, because we have -1 plus 1 equals 0. So this looks like -R2 plus R1 into R1. So we have the bottom row staying the same, row 2, 2, 1, -5. Top row is going to be changing. So what's the negative of the first entry of the bottom row? You have -2 is +2 and then you're going to add that to the top row. So +2 minus 1, top row first entry, -2, -2, +2 minus 1 is 1. And then -1 plus 1 is 0. -5 is +5 plus 4 is 9. And the notation that they'll use a squiggly line here, and then they'll tell you what elementary row operator they're doing. So for this next one, let's try and get rid of this -2 in the bottom row right here. And there's more reasoning to why we do this. It's sort of an algorithm that we lean on, but for now, let's just do these operations, and trust me that we're going to get to the answer in a second. So what we're going to do is do 2 row 1 plus row 2 into row 2. The reason I'm doing that, 2 times 1 is 2, and then we're going to add that to -2 to get 0. So top row is staying the same. Top row is staying the same. 1, 0, 9. Bottom row becomes 2 times the first entry, row 1, so 2 times 1 is 2, plus negative 2 is 0. And then 0 times 2 is 0, plus 1 is 1. And then 2 times 9 is 18, plus negative 5 is 13. And from here, when we have it written like this, we can simply pull out the answers as they are. So we have the coefficient of x. We have x, 1 times x equals 9. And then 1 times y equals 13. Otherwise written, x equals 9, y equals 13. And you can check in your calculator with the tips I gave you in one of my shorts that that's the correct answer. If you enjoyed this video, please leave a like and maybe subscribe to the channel if you want to see more things like this. I'm going to be doing partial differential equations, linear algebra, some digital logic, and a lot of imaginary numbers that will play a role in circuits. I don't know if I'll actually be covering circuits or just some of the math things inside of circuits, but yeah.